Hi, welcome to this latest edition of Lightboard Lessons, and today we're going to talk about iRules architecture. And we've had a video a couple months ago on iRules Anatomy, and we talked about the differences between like the tool command language, and which is a dynamically typed language, and something like C++, which is very statically typed. And so we're not really going to talk about the hows and whys of Tcl, but I will mention that the tool command language 8.4 is what iRules is based on. And of course, iRules has quite a few proprietary extensions to the tool command language, and it's embedded in TMOS. And so if you look at the TMOS system, we have on any given system, and it's different on whether or not you're using a virtual edition or a Viprion or some appliance somewhere in between. But say on a 4-core system, you have 4 TMMs running. And each of these TMMs is single-threaded. So you have a single-threaded event loop running on each TMM. And so when you have a client connection come through here in a server, you will maybe hit client 1, will hit, say, TMM, actually it'd be TMM 0, and TMM 1, 2, and 3. And say connection 1 hits TMM 0, say connection 2 comes in here and hits TMM 2, and then 3 hits, say, TMM 3. And of course our disaggregator, the DAG we call, is the one that is doing a hash algorithm to determine what connection goes to what TMM. And so that hashing algorithm makes sure that the client connections that come in that hit a particular TMM, they will then go to the server and then route back through that same TMM. So, we have some consistency going through and then back through. And so from an architecture standpoint, this works out really well. You're allowed to scale all of your connections, but there are some considerations when you write iRules. Say if you use boo, a global variable, well, that would pin all of your connections for that VIP would be bound to a single TMM because there's no sharing of data on global variables amongst TMM. And so you would be pinned to a single TMM. That's bad news. So instead, you would want to use something like static variables, or using the session table, where you can use the table command or persist connect, and there's information sharing between these. So most connections you don't need to share data amongst the TMMs because the data you're using is self-contained within a TMM. But some things like if you're doing any kind of statistical counting and you want to make sure that all the connections are accounted for, and then you need to share those across TMMs, or there's a particular data set that you need to be able to share amongst connections, then you definitely want to use these kinds of things versus just a locally scoped variable for a particular client. But so there are some of the processor-based reasons that CMP is important with iRules. But then I also want to talk about profiles and how important those are. And so if you have, you kind of have your kind of layer 3 stuff sitting down here, and then you have TMM here, and then you have, so you would hand a connection up here. And maybe you've seen this diagram before, but you have this idea of you're going to kind of climb the ladder, hit the proxy, and then you're going to go back out. So, this is maybe the server side, and this is the client side. And so you've got your L3, L4 stuff here that's being handled by the switch. But then also, you have access to some of that stuff in here, depending on what you do with profiles. So there is protocol validation that is done, even if you don't have profiles attached in some cases. I know with some of the DDoS stuff that there's protocol validation being done on your behalf. But as you come up into where the iRules play is, you have this layer where iRules can really interact with any stage along here, but that's dependent on whether or not you have profiles attached. So here at the TCP, let's say, in this little section, we have a TCP profile applied, and then that gives us access to the native TCP data. So, your TCP payload, in some cases, your TCP headers, and then say we have here, we've applied an SSL profile, and now we can get access to the handshake data and the certificates and all that. It's important to know that even if you don't have the SSL layer applied, because SSL rides on TCP, if you want to do binary decodes, you can do that here at the TCP layer. But because we have native decodes built for you, applying the SSL profile just makes sense, makes your iRules a lot easier. And then, of course, you can continue go down the path here with HTTP as we get up to layer 7 right before we hit the proxy. So here's your proxy. And then, let's say I burned up all my colors. We'll go back to orange. So, here we'll go HTTP. And so now I have access to my full layer 7 protocol. And so, HTTP cookies and requests and payload and whatnot, anything you want to do with that, you can access at the iRules level. And then, of course, on the other side of the proxy, you have access to this data as well as it falls back down the stack, as the HTTP gets wrapped up into the lower layer headers. You still have access to all that stuff, so you can make the changes you need to make before you send that out to the server, and vice versa. On the way back from the server, you can manipulate HTTP responses and whatnot. So highly recommend you dig into the details of CMP and what that means for iRules. Dig into the profiles and what that means for iRules. It will make you a much better author of your iRules. It will make you a lot more cognizant of what power you really are wielding when you write an iRule. So see you guys out there in the community. Thanks a lot.